Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at algebraic fractions. So these are just fractions with pronumerals in them. We treat them like ordinary fractions. So if I want to simplify this, that is write this as a single fraction, I do it the same way we always do. We need to make the denominators equal before we can add. So I'm going to times top and bottom of this fraction by denominator of the other fraction. And similarly, I'm going to times top and bottom by denominator of the other fraction. So the first fraction simply becomes x over x times x plus 2, and the second fraction becomes x plus 2 over that same denominator. So now that the denominators are the same, I keep the same denominator and simply add the tops. So x plus 2 gives me 2x plus 2, and on the bottom we have x lots of x plus 2. So this is as simple as it can get. Please don't try to cross out x here and x there. X is not a factor of the top. Factor means it's being multiplied. So we can't cross out anything there. We are done. All right, let's look at simplifying these algebraic fractions here. So when you see an expression on the top, that is multiple terms, see if you can factorize it. So let's start by factorizing this quadratic here. So we're going to use the AC method, A being 2, C being negative 12. We want two numbers that multiply to A times C, negative 24, and add to negative 5. So going through the factors of 24, we see those numbers are negative 8 and positive 3. So we split up the middle term accordingly. I'm going to rewrite it as 2x squared minus 8x plus 3x minus 12. Again, the reason I chose negative 8 and 3 of all the possible factors of this number, they are the two numbers that multiply to negative 24, that is multiply to AC, and add to B, the middle coefficient. So now we factorize the first two using highest common factor. Highest common factor is 2x. And then we factorize the last two terms using the highest common factor. This time the highest common factor is 3. Now when we're doing this, these two brackets need to be the same, which they are. So we just combine x minus 4 is now the common factor. And what's left, which is 2x plus 3, goes in the second bracket. So the other ones are all easy to factorize. Highest common factor, difference of two squares, and we use the product sum rule here. So when we are dividing fractions, as with normal non-algebraic fractions, we flip the second fraction and change this to a times. So now that we're multiplying, we can cross off any factor that appears on the top and the bottom. So x minus 4 is on top and bottom, x plus 4, top and bottom, x plus 1, top and bottom. And we're just left with 2x plus 3 over x. That is our final simplified answer. Once again, please don't try to cross out the x's. X is not a factor of the top. We can't simplify anymore. All right, let's take a look now at partial fractions. So partial fractions come up in calculus, in integration. So sometimes we have to integrate something like this, but it's so much easier to integrate if it's written in this form. These are partial fractions. You'll note that the two denominators are precisely the factors of the denominator of our original fraction. So we're going to find A, B, and C to make this statement true, and thus decompose this into partial fractions. So that's actually pretty easy to do. What we're going to do is start with this, and we're going to do as we did in the first example. We're going to multiply this by the denominator of the other fraction, and then we're going to multiply this, that is top and bottom, by the denominator of the other fraction. And of course we want this to equal our original fraction, 6x squared plus 9x minus 9 over x squared bracket x plus 3. Now if these two are equal, Because their denominators are equal, so too the numerators must be equal. So this numerator here must be equal to this plus this. So we'll leave the ax squared as it is. What we're going to do is expand the brackets here using FOIL. So remember, when you expand, you need to multiply everything in the first bracket by everything in the second bracket. So we go bx times x, bx times 3, c times x, and c times 3. So now, in order to make these expressions equal, every coefficient has to be equal. Now you can see 3c here is the only term on the right hand side that doesn't have an x attached to it. It's the constant term. So immediately we can see that 3c has to equal -9, which of course means c equals -3. So if these two expressions are to be equal, the terms with just an x have to be equal. So we must have that 9x is equal to 3bx plus cx. But wait a minute, we just figured out that c is -3. So we'll rub out c and replace it with -3. So that means 3b has to be 12, because 12x minus 3x is 9x. And of course 3b equals 12 implies b equals 4. Now let's look at the x squared terms. If these two expressions are to be equal, the x squared terms must agree. But of course, we just figured out that b is equal to 4. So I'm going to rub out b and replace it with 4. And that, of course, means that a equals 2. 2x squared plus 4x squared equals 6x squared. So that means that this expression here can be decomposed as 2 over x plus 3 plus b is 4x plus c over x squared. And again, this is very useful in things like calculus. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.